Hi all. So in this session, we are going to discuss homework 3 of TOC, Theory of Computation, homework 3. Okay, so these questions we are going to discuss. In this homework, we have top university homework questions. Okay, from many different universities, I have collected the questions, and those questions we are going to solve in this session. Okay, so let's start. Let's start with our question number 1, that is Fordham University question. So this is a very simple question. Let M be a deterministic finite automata. This is a DFA that is given to you. The question is asking, provide the formal description of M. Okay, so we need to give the formal description of M. This is your machine. We need to provide the formal description of this machine. Also, we need to provide what is the language accepted by this DFA. What is the language described by this DFA? That also we need to tell. Okay, so these are the two questions. So let's see the first question. The first question is, provide the formal description of M. Remember, this machine is given to you, but this diagram is given to you, remember. Okay, so basically this machine's diagram representation is given to you. I can say that for this machine, for this DFA, diagram representation has been provided to you. Okay, now from this diagram representation, we need to convert this diagram representation into formal description. Formal description means the 5 tuples. I told you that DFA has 5 tuples, right? Any DFA, if you take any DFA M, that will have 5 things. There are 5 things. One is set of states. Another is what is the alphabet. Another is what is the initial state. Another is what is the set of final states. And another is what is the transition function. So these are the 5 things any DFA has. Yes or no? This is called the formal description. Let me tell you, this is called the formal description. So any DFA has only 5 things. There are 5 things. There are 5 properties of a DFA. So these are the 5 properties of a DFA. Now we need to provide what are these 5 things for this particular DFA M. So tell me, what is the set of states? What is the set of states? So set of states is Q0, Q1, Q2, Q3. This is the set of states, right? Yes or no? So the set of states, that will be Q0, Q1, Q2, Q3. Okay. Next, tell me what is the alphabet? DFA is given to you. What is the alphabet? What is the alphabet? So you can notice alphabet is binary alphabet, that is 0, 1. This is the binary alphabet, that is 0, 1. What is the initial state? What is the initial state in this DFA? What is the initial state? This arrow means initial state. You can notice. Okay. So remember this arrow which is coming from nowhere. This arrow, this means initial state. So Q0 is the initial state. So initial state is Q0. Okay. Next, what is the set of final states? What is the set of final states? So set of final states, that is Q2. This double circle means final state. Okay. This double circle, you can notice this is your, I can say this is the double circle. This double circle, it indicates the final states. So I can say this Q2, set of final states. This is the set of final states. Now, finally, we need to tell what is the transition function. Yes or no? This transition function, this is also we need to tell. What is the transition function? Okay, so let's describe the transition function also. So the transition function, tell me in a DFA, how do we write the transition function? What is the definition of transition function in a DFA? This is called transition function. So what is the input of transition function? Tell me, what will be the input of transition function? Input is you are in some state and you read some symbol. Yes or no? You are in some state, you read some symbol, and output is you go to some states. Okay, so remember, this is the transition function. So you can notice the transition function. What is the definition of transition function? You are in some state, you read alphabet symbol, and you go to some state. Okay, so now you can easily notice we can describe the transition function like this. You have these states Q0, Q1, Q2, Q3. These are the states that we have. And what are the alphabet symbols? So remember, this is the initial state. This is your initial state. And what is the final state? This Q2. This Q2 is the final state. So you can put star. So this representation of, I can say, transition function. This representation, this matrix representation of transition function, this is called transition table. Okay, this is called transition table. Remember. Okay, so basically we are creating the transition table representation of transition function. We know what is the transition function in DFA. In DFA transition function, the input will be you are in some state and you read some input symbol. Okay, so then you will go to some state. So this is the transition function definition. Now these are the states, these are your states, and these are the input symbols, because your alphabet is what? Your alphabet is 0, 1. This is your alphabet. So now you tell me, in state Q0, if you read 0, 1, then where you will go? In state Q0, if I read 0, in this state Q0, you are in this state Q0. If in this state Q0, you read the symbol 0, then you will go to state Q1, right? You are here. And in this state, if you read symbol 0, then you will go to state Q1. Okay, so this is the idea. So remember this point, that you are in state Q0. And if you read the symbol 0, then where you will go? This is transition function. This means transition function. This means transition function. So if the input is this, then what will be the output? If the input is this, to this transition function, remember, this is your transition function. To this transition function, if input is Q0, 0, if this is the input, then what will be the output? The output is going to be Q1. Okay, so you will go to state Q1. Very simple. So this is the idea. So this is your transition function. Remember, very simple point, that to this transition function, if the input is Q0, 0, then output will be Q1. What it means? It means that in this state, if the input is 0, if I read the input 0, then I will go to state Q1. Okay, so very simple idea, that in this state, if you are in this state and you read input 0, then you will go to state Q1. This is the idea. So very easily I can say that in this state Q1, you read 0, in this state Q0, if I read symbol 0, I will go to state Q1. Okay, tell me the next. What about Q0, 1? That will be Q0. In this state Q0, if I read symbol 1, then I will go to state Q0. So I can say this is going to be Q0 itself. Next, tell me, what about Q1? Where Q1 will go on 0, 1? This Q1, on 0, it will go to Q2. On 1, it will go to Q1. Okay, so very simple, I can say on 0, it will go to Q2. And on 1, it will go to Q1. Next, what about Q2? What about Q2? You can notice this Q2. On 0, it will go to Q3. On 0, it will go to Q3. On 1, it will go to Q2. Okay, so very simple point, that this Q2, on symbol 0, it will go to Q3. On symbol 1, it will go to Q2. What about Q3? What about Q3? What can you say about Q3? So this Q3, on 0, 1, it will go to Q3 itself. This is a self loop. You can notice in this Q3, if you read 0, you will go to Q3. If you read 1, you will go to Q3. So there is a self loop. So I can say Q3, when you read symbol 0, then you will go to Q3. In state Q3, if you read symbol 1, you will go to state Q3. So this is your transition table that we have created. So very simple. This is your formal description. The question is asking formal description. So remember, any DFA has 5 things. Yes or no? Every DFA is a 5 tuple. DFA is defined as 5 tuple. DFA is defined. We can define DFA as 5 tuples. 5 tuples. What are those 5 tuples? 5 tuples. These are the 5 tuples. Set of states, alphabet, initial state, set of final states, and transition function. So this is the, I can say this is the formal description of DFA. So DFA is defined as 5 tuples. These are the 5 tuples. Okay, so let's move on now. Now the question is asking, what is the language of this DFA? So this DFA that is given to you, what is the language of this DFA? Can anyone tell me? Can anyone tell me what is the language of this DFA? See, in the GATE exam, if they give you some DFA and some options are there in the GATE exam, just think about it. In those 3 hours, when you are in the GATE exam, I'm talking about GATE exam 3 hours, those 3 hours. Okay, so in those 3 hours, there will be options A, B, C, D, there will be options. Yes or no? Agree? So you can notice if the DFA is complicated. See, this DFA is very simple. Remember, this DFA that is very simple. This is a standard DFA. But if the DFA is complicated, if you do not get the idea of language, you are not understanding what is the language. Okay, let's assume. Then in that case, what you can do, tell me? There will be options. The question is asking what is the language. The question is asking what is the language. So tell me what you will do. You can eliminate the options. You can eliminate the options, you can verify the options, and you can remove the options. For example, you can see that, let's assume that I say that at least 20. Let's assume option A is at least 20. Then what you will do? Let's assume option A, that is all the strings with at least 2 zeros. All the strings with at least 20. Let's assume this is your option A. How will you remove this option? How can you eliminate this option? This option is wrong. This option will be wrong. This is not the language. How can you eliminate? What will be the counter example? What you can do in the GATE exam in those 3 hours? If the DFA is complicated, again I am telling you, if the DFA is complicated, you can eliminate the options, you can verify the options, and you can remove the options. But remember, this DFA is standard. Okay, this DFA, this is a very simple DFA. This is a standard DFA. You can easily find out the language. You can directly find out the language. But if the question is complicated, then you can eliminate the options. For example, if this is your option, option A, if this is your option, then what will be the counter example? The counter example will be 000. According to option A, this should be accepted or rejected. According to option A, this should be accepted or rejected. This should be accepted according to option A. According to option A, this should be accepted, but this is rejected. Yes or no? You can notice this DFAM, this will reject. This will reject, but option A accept. Yes or no? But option A accepts. So this is the counter example. Remember, this is the counter example. Option A will accept and DFA will reject. So I can say this option is a wrong option. So I can say this option, I can say this option you can eliminate. This option can be eliminated. So very easily, because you can notice 000 is not accepted. You can notice, okay, from the initial state on 000, you will go to non-final state. From the initial state, when you read 000, when you read 000, then you will go to non-final state. So this is the idea. I hope this idea is clear. So you can remove the options. Tell me another. If the option is this, at most at most 2 zeros. Sorry, at most 2 zeros. If this is your option B, at most 2 zeros, then what counter example you will take? If this is your option B is at most 2 zeros, at most 2 zeros. So here again, this option is wrong. And what you can do, you can give a counter example. You can easily take a counter example. The counter example you can take, that is 0. This counter example you can take. This counter example you can take. According to option B, this should be accepted. According to option B, this should be accepted. But this DFA will not accept it. But this DFA will reject. So this option also eliminated. This option also you can eliminate. So this is the idea. Anyway, now let's come to this DFA. This is a standard DFA. So let's find out, let's analyze and find the language. Okay. So you tell me, can you notice what is happening here? This is your final state. This is the final state. Here you want to go. So tell me, can you notice that if ones are coming, you ignore them? Yes or no? If ones are coming, any number of ones you will ignore. Any number of ones you will ignore. Any number of ones you will ignore. Then 0 should come. Then 0 should come. Okay. After that, any number of ones you will ignore. Yes or no? Okay. So remember, initially any number of ones you can ignore. Then 0 should come. Then any number of ones you can ignore. Then again 0 should come. Then again 0 should come. Okay. Now this is accepted. And okay, now this is accepted. And you can notice in the final state, any number of ones can come. In the final state, any number of ones can come. This is your language. You can easily notice this is your language. So can you notice this is exactly 2 zeros? Yes or no? This is the language where we have exactly 2 zeros. Okay. So the idea is very simple. If you look at this DFA, see this DFA is accepting those binary strings which contain exactly 2 zeros. When you have 2 zeros, you will go to final state. If you have more than 2 zeros, then you are going to the dead state. Yes or no? Then you are going to the dead state. Agree? Agree or not? So you can notice, if you have 2 zeros, if your string contains 2 zeros, you will go to final state. If you have more than 2 zeros, then you are going to dead state. So very simple, that this DFA is accepting exactly 2 zeros. So I can say, what is the language of this DFA? That will be binary strings. That will be binary strings with exactly 2 zeros. Exactly two zeros. Okay, very simple. This is the idea. Okay, set of all. So I can say set of all binary strings. Set of all binary strings with exactly 2 zeros. Is this point clear to everyone? Please tell me. Please tell me, is this clear? This is the idea. Okay, so let's move on now. So you can see this is the answer. Contains exactly 2 zeros. This is the answer, and this is your transition table. Now let's see another question. Question number 2. This is from Duke University. Okay, so let's see this question. So 2 questions you have. So let's solve them. Let's see the first question. This is a regular expression question. The question is asking, write a regular expression for all strings of A's and B's which contain the substring ABBA. Okay, so we want regular expression for all strings of A, B which contain substring ABBA. So remember, what type of strings we want? Tell me what type of strings we want. We want in this string we want ABBA. This is what we want. Okay, remember, we want to contain substring ABBA. Okay, tell me here what we can have. Here you can have anything. Any string. Here you can put any string. So remember, here you can put any string, and here you can put any string. Anything means what? Anything means any string you can put. Okay, any string you can put. You can put any string from A, B whole star. So your expression, what your regular expression will be? So your final regular expression, that will be that anything can come, any string can come. Remember, here any string can come. You can put any string. Here you can put any string. Any string means any string from sigma star. This is your sigma star. So any string from sigma star can come. Then this substring must come. This substring must come. And then any string can come. So very simple. Your regular expression is basically sigma star, and then ABBA, then sigma star. This will be your regular expression. Okay, so this is the correct regular expression. Very simple. This is a very simple question. Now let's see the next question. Question number 2. Write a regular expression for all strings of x, y, where every y is immediately followed by at least 3x. This template we have already seen, if you remember. So let's see this template again. The question is saying, write a regular expression for all strings of x, y. All string of x, y, where every y is immediately followed by at least 3x. Can you tell me one thing? Which two people will repeat in your string? Okay, which two people you will see in your string? See, let's see idea number 1. Let me tell you, this regular expression you can write in 3 different ways. Okay, this regular expression you can write in 3 different ways. I will write this. This regular expression you can write in many different ways. There are many different ways. To write. Okay, it's all about idea. Many different ways. These are simple ideas. Many different ideas. Okay, so you tell me what is the first idea. Let's see idea number 1. This idea number 1, you tell me one thing. Okay, I'm asking one thing, you tell me that. In your string, which 2 people you will see? Which 2 people you expect to see? In your string, which 2 people will keep appearing? Which 2 people will keep appearing? Very simple question I am asking. In your string, which 2 people will keep appearing? Is there any restriction on x? There is no restriction on x. Remember, we have no restriction. We have no limitation on x. Okay, remember, every y should be immediately followed by triple x. Means if y comes, if you see this y, then it should be followed by at least 3x. But the point is there is no limitation on x. So this x can appear. So this x, I can say this in this idea number 1, I am saying that this x can appear any number of times. Okay, this x, this can appear any number of times. Okay, what other things you will see in your string? What other things you are expecting to see? You can see that if this person is coming, then it will come with bodyguards. Agree with me? Yes or no? If this person is coming, every y, remember this point, every y is immediately followed by at least 3x. So if this person is coming, it simply means who is coming. It simply means who is coming. It simply means this person is coming. Agree with me? Okay, yes or no? So I can say that these three people. So ultimately I am saying that this also these two people will repeat in your string. Do you agree with me that in your string these two people will keep repeating? These two people will keep repeating. You can notice these two people will keep repeating. Please understand, very simple idea, very simple idea, that these two people will keep repeating. These two people will keep repeating. Okay, so in your string, this is what I'm saying, that in your string, these two people will keep repeating. You can easily notice. You can see. Okay, so this is the point, that these two people, they will keep repeating. So anyway, now you tell me what will be your answer. So I can say that this person and this person, they can repeat any number of times. Okay, and they can mix. Yes or no? They can mix and match. So I can say this person or this person, these two people can repeat any number of times. These two people can repeat any number of times. Yes or no? Agree with me? Can I write like this? Is this correct? If I write like this, then will it be correct? For example, if I say x star, means this is repeating, or yxx whole star, means should I write like this? Should I write like this? Should I write like this? Tell me. No, this will be wrong. This will be wrong, because what is the reason? The reason is simple. Remember, they can mix and match. They can mix also. Yes or no? They can mix also. Agree with me? They can mix also. For example, this type of strings are also possible, x, y, xx. Okay, because they can mix also. These two people, they can mix also. Please understand, these two people, they can mix also. They can mix also. Okay, so very simply you can see that this regular expression will be wrong, but this regular expression is correct. Did you understand this idea? Please tell me, this idea number 1, did you understand? This is very interesting idea. Yes or no? Agree with me? This is quite interesting. Very simple. And this idea you can use in many different languages. When you write the regular expression, this idea you can use for many languages. So this idea, did you understand this idea? The idea is very simple. Remember, the final idea, this is the conclusion. This is what we want. What we want in string. We want what we want in our string. Okay, so just notice what we want. What we want in our string. In our string, we want only two people. These people can come, and also these people. These, basically, it's like you can put them in the box. You can put them in the box. This you can put in the box. This you can put in the box. And these two people can repeat any number of times. Yes or no? These two people can repeat. We can repeat these two people. These two people can repeat any number of times. Any number of times in any order. In any order. Okay, these two people, they can repeat any number of times in any order. So finally your answer will be that this person, also this person, these two people, they can repeat any number of times in any order. This will be your final answer. Okay, so this is your idea number 1. Now let's see idea number 2. What is that? Let's see idea number 2. So tell me, what is that? See, you focus one thing. You focus on one thing. Let's see like this. This is your string. Okay, so let's see. This is the string that you have. So you tell me, if x are coming, is there any problem? If x are coming, is there any problem? There is no problem, right? We have no problem with x. If y is coming, then who will come together? If y is coming, then who will come together? 3x, at least 3x will come together. At least 3x will come together. So notice one thing. If these people are coming, there is no problem. If these people are coming, there is no problem, no problem. Now, if this person comes, okay, so understand, if this is a if y does not come, is there any problem? If y does not come, let's assume in your string you don't have y. In your string you don't have y, then do you worry? Then do you care? Okay, then tell me. No problem. Then no problem. Remember, if y comes, then it should come with 3 bodyguards. Yes or no? So remember this point. If y comes, then immediately it comes with triple, I can say at least triple x. Okay, yes or no? If y comes, it comes with at least 3 x's. Okay, so very simple point. So remember, I am saying that if x are coming, no problem. If this y is coming, then it will come with at least triple x. Now, after that, any number of x can come. Yes or no? Any number of x can come. Now, can you notice which story can repeat? See, this story can again repeat. Agree with me? See, again y can come. Again, what can happen? Again, y can come. Again, y can come. It will come with triple x. Then again, any number of x can come. Then again, what can happen? Then again, what can happen? Again, y can come. Again, y can come. Then again. So can you notice what is happening? Please tell me. Again, y can come. It will come with at least triple x. Then again, x will repeat. So please tell me where recursion is happening. Where can you apply the recursion? Where can you apply the recursion? Where can you apply the recursion? Can you notice this structure? Please look at this structure. Can you notice this structure is repeating? Can you notice this structure is repeating? Yes or no? Please notice. Can you see this structure is repeating? Do you agree with me? This structure can repeat. So that's it. So finally, your answer is what? Your answer is any number of x can come. Your answer will be that any number of x can come. Then this structure can repeat any number of times. Please notice this structure. Which structure? X, x, x. Then this is x star. This is x star. And this structure can repeat any number of times. This will be your answer. So please tell me, did you understand the idea number 2? Please tell me, did you understand the idea number 2? Remember, very simple. Any number of x can come. Then this structure is repeating. This structure is repeating. You can notice this structure. This structure is repeating any number of times. Okay, very simple. Understood? Is this idea clear? Now let's see the idea number 3. The idea number 3. What is the idea number 3? See, what you can do, you can repeat the same structure. See, notice that any number of x can come. Now, if y is coming, it will come with 3 bodyguards. Okay, yes or no? Now, again, what can happen? Any number of x can come. Then again, if y is coming, it will come with bodyguards. If y is coming, it will come with bodyguards. Then again, x can come. Any number of x can come. If y is coming, then it will come with bodyguard. Then, okay, yes or no? Agree with me? Let's assume this is the last y. Let's assume this is the last y. Let me assume this is the last y. Now, what can happen? Then, in the end, you will have any number of x. Any number of x can be there in the end. Now, you tell me, see, in the idea number 2, what we did? Please tell me, in the idea number 2, what we did? You just tell me one thing. In the idea number 2, what we did? In the idea number 2, where we started the recursion? In the idea number 2, where we started the recursion, we started, this structure was repeating. Yes or no? In the idea number 2, this structure was repeating. In the idea number 2, this structure was repeating. Please understand. In the idea number 2, in this idea number 2, this structure was repeating. So in the idea number 2, your answer was x star, and this structure was repeating. In the idea number 3, what you can do? Please tell me. In the idea number 3, can you repeat this structure? Can you see? Can you see this structure is repeating? Can you notice? Please tell me. Please tell me, can you notice this structure is repeating? Can you notice this structure is repeating? So the same thing, yes or no? Agree with me? See, very beautiful thing is happening. Basically, in the idea number 2, we were saying that this structure is repeating. In the idea number 2, this is what we were saying, that this is repeating. But in the idea number 3, I can say that this is repeating. In the idea number 3, I can say that this structure is repeating. So finally, your answer will be that x star y x x x, this structure is repeating. This structure is repeating. And finally, at the end, you have any number of x. At the end, you have any number of x. So this is your answer. Please tell me, did you understand? Did you notice one thing? Did you notice one thing? This type of strings we want. Please notice what is happening. See, something very interesting. See, this type of string we want. Agree with me? This type of strings we want. Strings we want. Do you agree that this type of strings we want? Agree? Yes or no? This type of strings. Please tell me. So this type of strings we want. Now, from this, now you can create many ideas. From this, you can create idea number 2. From this, you can create idea number 2. And from this, you can create idea number 3. Idea number 2 means you are saying that this is repeating. Then idea number 2 will come. Okay. And if you say that this is repeating, then idea number 3 will come. Okay. So very simple. So you can create idea number 2, idea number 3. In the idea number 2, what you will say? In the idea number 2, you will say that any number of x can come. Any number of x can come. And then this structure is repeating. This structure is repeating. So I can say like y x x x x star, this structure is repeating. In the idea number 3, what will happen? In the idea number 3, you will change your thinking. Yes or no? We are changing our thinking. Can you notice? We are basically, we are looking at the same string from a different point of view. These ideas are point of view. Yes or no? This idea number 2 is a different point of view. And this idea number 3 is a different point of view. We are changing our point of view. Okay. So in the idea number 3, I am changing my point of view. I am saying that this structure is repeating. And then at the end, x star. Okay. So very simple. Your answer will be x star y x x x, this whole star at the end x star. So these are the different point of view. Okay, I hope all these points are clear. Please tell me, did you understand? And from the same, from this, you can create the idea number 3, idea number 1 also. Okay, if you see like this, if you look like this, then you will see your idea number 1 also. In the idea number 1, you can notice that these two people are repeating. Basically, this person or this person, these two people are repeating any number of times. This is your idea number 1. So idea number 1, idea number 2, idea number 3. So we have seen these expressions. So tell me, did you understand? Let me tell you in the GATE exam what will happen. For this language, in the GATE exam, what will happen? Tell me, can anyone tell me in the GATE exam what they will do? In the GATE exam, MSQ question can come. Okay, they will give you MSQ question. In that, option 1 will be your idea number 1. Okay, option 1 will be idea number 1. Option number 2 will be idea number 2. Option number 3 will be some wrong answer. And option number 4 will be, that will be your idea number 3. Your idea number 3. So very simple. This is what they will do in the GATE exam. Okay. See, can you tell me what is the mistake people can do? This wrong option also will be very common mistake. This wrong option also will be very common mistake. Very common mistake. This wrong option, this will be very common mistake. Can anyone tell me what is the common mistake people will do? Can anyone tell me what is the common mistake people will do? See, people can do this common mistake. In the idea number 3, this common mistake they can do. At the end, this x star they can forget. See, in the idea number 3, people can forget this. At the end, they can forget this star. So for example, if you remove this is a common mistake. Yes or no? If you put like this will be a wrong option. I hope you are getting the answer. So I am saying that this is correct, but this will be wrong. Yes or no? This will be wrong. Is this point clear? Please tell me. In the idea number 3, people can forget about these x. Okay. But anyway, tell me one thing. If you see this option, tell me one thing. In the exam, if they give you this option, if this is your option number 3, then can you eliminate this? Let's assume this is option number 3. Let me assume this is option number 3. Can you eliminate this? Yes, you can easily eliminate. Can you notice that in this, how will you eliminate? Tell me. In this, how will you eliminate? How to eliminate this? You cannot create. Can you create double X? Can you create double X? Can you create X? Can you create these strings? These strings you cannot create. These strings you cannot create. Can you notice? If I take it 1, if I take it 1, then definitely this will come. Then definitely this will come. Agree with me? If I take this star equal to 1, then definitely this will come. Definitely this will come. So can you notice that these strings cannot be created from this. Okay, from this you cannot create this. From this you cannot create this. Okay, so this is how you can eliminate option C. Okay, so option C eliminated. Please tell me, did you get it? Please tell me, did you understand? If your option 3 is this, if this is your option 3, you can eliminate this, because you can easily notice that this double X cannot be created. This X cannot be created. But remember, they belong to the language. But remember, they belong to the language. They belong to the language. This X belongs to the language. This double X belongs to the language. So remember this point. They belong to the language. I hope this point is clear. Okay, so very easily you can do all these things. Okay, very simple. You tell me one more thing. Some variations I am asking. You tell me, you know the answer is this. You know that this is correct answer. X or YXX whole star. You know this is the correct answer. Tell me, will this be correct answer? Will this be a correct answer? What about this? See, this is your idea number 1. This is your idea number 1, and this is a correct answer. This is a correct answer. You tell me, will this be a correct answer? Will this be a correct answer? Yes. Which property you will apply? Tell me which property you can apply. Which property can you apply? Remember this property we have already seen, that R or S whole star, that is same as R star or S star whole star. Do you remember these properties we have seen? For example, we have seen this property that this is your sigma star. Yes or no? This is your sigma star. This is your sigma star. And that is same as you can put A star or B star whole star. So this is also sigma star. Okay, these we have seen. These we have already seen. The proof we have seen. With proof, we have studied these. We have studied with proof. With proof we have studied. Yes or no? You don't have to by heart. You just have to understand. Please tell me, did you understand? Yes or no? This option is also correct. This option is also correct. This option is also correct. Remember this point. This is basically redundant. Can I say this is like redundant? This is just extra. I can say this is redundant. This is not wrong. This is not wrong. Remember, this is not wrong. This is redundant. They can create any option they want. See, your answer, like this is your answer, that X or YXXX whole star. This is your answer. Now they can create any answer they want. For example, they can create X star, or they can create YXXX. Okay, and they can create, for example, they can also put X star here, then whole star. Yes or no? This is also correct. This answer is also correct. There is no mistake in this answer also, because we have no problem with X. Agree with me? Do you agree with me that this person should be there? This person should be there. We have no problem with extra X. We have no problem with extra X. There is no problem with extra X. So this answer is also correct, because the answer is very simple. See the logic. Let me tell you the logic. What is the logic? This is the logic that this must be there. This is important person. This is important person. Yes or no? This person is important. We can have extra X. We can have extra X anytime we want. We can have any extra X's. We don't care about X's. We can have any extra X's. Yes or no? There is no problem with the X's. You can have any extra X's in the language. Do you agree with me that in the language you can put any extra X's? At any point you can put extra X's. At any point you can put just extra X's. You can put no problem. So we have no problem with the extra X's. Is this point clear? So this is also correct regular expression. Okay, because the rule, this is the logic. We can put any number of extra x. We have no problem with any number of extra x. So this is the idea. Please tell me, did you understand all these logics? I have done the complete analysis of this question. Different regular expression I have given to you. Okay, so let's move on. So you can see this is your final answer. Okay, every y is followed by immediately by at least 3x. This is your final answer. This is your idea number 1. Is this the complete analysis? Is this the complete analysis? No. This is the idea number 1. You can create idea number 2. You can create idea number 3. So different expressions you can create. Okay, so let's move on. Now let's see the question number 3, that is from Fordham University. So let's see this. The question is asking, assume the alphabet is 0, 1. Draw the simplest possible DFA. The question is asking, draw the simplest possible DFA. We need to create the simplest possible DFA. Simplest possible DFA means in terms of states and arcs. So you tell me one thing. Minimal DFA, simplest possible DFA means minimal DFA. You tell me minimal DFA, is this unique? Is this unique? Minimal DFA, is this unique? Unique. Yes, this will be unique. Minimal DFA is always unique. Okay, so you don't have to worry about this. Minimal DFA will always be unique. So we need to create minimal DFA for this language where you have ending with 0, 0. So can you create DFA for DFA? Let's create the minimal DFA. We will directly create the minimal DFA. Let's create minimal DFA for ending with 0, 0. Ending with 0, 0. We want to end with 0, 0. So tell me what you will do from the initial state. What you will do? This is your initial state and we want to end with 0, 0. If ones are coming, do I care? Remember, I want to end with 0, 0. This is my focus. My focus is to end with 0, 0. I want to end with 0, 0. This is what I want. At the end, I want 0, 0. So you tell me, if ones are coming, do I care about them? I will ignore. I am waiting to end with 0, 0. So remember, in the initial state, I am waiting to end with 0, 0. In this initial state, this is your initial state. In this initial state, I am waiting for 0, 0. Okay, in this state, if ones are coming, I will ignore. If 0 will come, then I'm thinking that I have seen 1, 0. Now I'm waiting for one more 0. I have seen 0. I'm waiting for one more 0. Now this state is done. Now in this state, if I see another 0, now I have seen 0, 0. What I'm thinking? I'm thinking that I have ended with 0, 0. What I'm thinking? I am thinking that I have ended with 0, 0. This is what I am thinking. In this state, I am thinking that I have ended with 0, 0. In this state, I am waiting for 0. If 1 comes, what I will do? In this state, let's call it state A, let's call it state B, let's call it state C. This is state B, this is state C. So you tell me, in this state B, remember what this state B is telling you. If you notice this state B, this state B is saying that I have seen 0. So far, I have seen 0 at the end. So far. Okay, this is now. Okay, so this is what state B. Here, your state B. So you can notice this is what you have seen. Okay, this is your state B. I can say here your state B is there. So you tell me now, after this, if 1 comes, then what I will do? Now I need to wait for 0, 0. Yes or no? Whole progress gone. Agree with me? Okay, agree with me? Now the whole progress is gone. Then again I will wait for 0, 0. Again I will wait for 0, 0. Basically the whole progress gone. If this 1 comes, then whole progress, then the complete progress gone. Whole progress is gone. So very simple. I can say that I will go to this state. Okay, again I will wait for 0, 0. Again I will wait for 0, 0. Now this state is over. Okay, this state is done. In this state, I am thinking that I have ended with 0, 0. If another 0 comes, I have ended with 0, 0. If another 0 comes, no problem. Still I am ending with 0. Still I am ending with 0, 0. In this state, if 1 comes, what will happen? In this state C. In this state C, I am thinking that I am ended with 0, 0. This is where state C is. Your state C is thinking that I have ended with 0, 0. I have ended with 0, 0. If 1 comes, then again you will wait for 0, 0. Then again you will wait for 0, 0. Basically, if this 1 comes, then the whole progress gone. Then again the whole progress is gone. Okay, so very simple. I can say that in this state, if 1 comes, I will go to this state. I will go to this state. This is your DFA. What will be the final state? This is your final state. So your answer is, this is your DFA, 3-state DFA. Yes or no? So finally, the answer will be 3 states. There will be 3 states in the minimal DFA. 3 states in minimal DFA. This is your final answer. Okay, now let's create the NFA. For the same language, let's create minimal NFA. Okay, minimal NFA. Let me tell you one thing. Minimal NFA is not unique. Okay, minimal NFA is not unique. But all the minimal NFAs, they will have same number of states. See, minimal NFA is not unique. But all the minimal NFAs, they will have the same number of states. Means I can ask you, what are the number of states in the minimal NFA? This question I can ask you. I can ask you, what is the number of states in the minimal NFA? But remember, I cannot ask you what is the minimal NFA. Yes or no? Agree with me? I cannot ask what is the minimal NFA, because that is not unique. You can create many different NFAs with 3 states or 2 states. For example, now let's create the NFA for this. See, let's see the NFA for this ending with 0, 0. So you can notice initially anything can come. Initially anything can come. Anything. See, ending with 0, 0 means ending with 0, 0. What that means? That means that anything can come. Here you can put anything, but you should end with 0, 0. Okay, here you can put anything. Here you can put anything. Anything means sigma star. Here you can put anything, and then what should happen? Then 0, 0 should come. Then 0, 0 should come. That's it. This is your NFA. State A, state B, state C. This is your NFA. So tell me, minimal NFA will have how many states? What is the number of states in minimal NFA? What is the number of states in minimal NFA? So minimal NFA will have how many states? That number of states will be 3. Number of states will be 3. Is this point clear? Remember, minimal NFA is not unique. Minimal NFA is not unique. For example, if I put this extra zeros, then also the same. Yes or no? Agree with me? See, notice what I'm saying. I'm saying that if I put some extra zeros, then also this NFA, this is also NFA with 3 states. This is also NFA with 3 states. So can you notice minimal NFA is not unique? See, this NFA is also correct. This NFA is also correct. In this NFA, you have 3 states. In this NFA also, you have 3 states. So can you notice minimal NFA is not unique, but number of states I can ask. Is this point clear? Please tell me, is this point clear that minimal NFA is not unique? Minimal NFA is not unique. But I can ask. But we can ask number of states in the minimal NFA. But all minimal NFAs will have same number of states. But all minimal NFA, that is the meaning of minimal NFA. That is the meaning of minimal NFA. Minimal means minimal. Means there is no one less than this. So this is your minimal NFA. So I can say minimal NFA is not unique, but all minimal NFAs have same number of states. Have same number of states. Number of states. So we can ask number of states in minimal NFA. Okay, so this question is valid. Which question is valid? So number of states in minimal NFA. In minimal NFA, this is a valid question. This is a valid question. Okay, this is a valid question. In the GATE exam, they can ask you number of states in minimal NFA. Okay, so I hope this point is clear. So you can notice this NFA, this also has 3 states. This NFA, this also has 3 states. For the same language, you have 2 NFA with 3 states. So minimal NFA is not unique. Okay, minimal NFA is not unique. Okay, is this point clear? Let me know. So very simple. You can also create this NFA. For example, you can put 0 here also. Will the language change if I do this? If I do this, will the language change? If I do this, will the language change? No, the language will not change. So can you notice this is your minimal NFA 3. I can say this is your minimal NFA 3. This is your minimal NFA 2. And this is your minimal NFA 1. Okay, so very simple. Is this point clear? Yes or no? See, someone is asking that all the minimal NFA, basically minimal NFA simply means, see, this NFA, this is also accepting the same language. This NFA, look at this NFA, this is also accepting the same language. This NFA is also accepting the same language. This NFA is also accepting the same language. These NFA, they are accepting the same language. And they have 3 states. This NFA has 3 states. This NFA has 3 states. And also you can notice this NFA has 3 states. So basically I can say that for the same language, you have many different NFAs which have 3 states. For the same language, the language is same. For the same language, you can create many different NFA with which have 3 states. So I can say minimal NFA is not unique. You can create different minimal NFAs. Yes or no? For the same language, I can create many different NFAs with 3 states. So that is the reason I am saying that minimal NFA is not unique. This minimal NFA, this is not unique. But all the minimal NFA, they will have same number of states. All of them, they will have same number of states. So I can say that number of states I can ask. In the GATE exam, they can ask you number of states in minimal NFA. Okay. So just create one minimal NFA, that's it. Just create one minimal NFA, that's it. For example, you can create this and you can say number of states will be 3. So this is your answer. Is this point clear? The question is asking, so we have done NFA, we have seen NFA also. Now, what is the regular expression for this language? Tell me. For this language ending with 00, what is the regular expression ending with 00? Remember, we want to end with 00. This is what we want. We want to end with 00. Here I can put anything, any string I can put here. Anything means sigma star. Anything means sigma star. So remember, I can put any string. I can put any string. At the end, I should have 00. Okay, so that is same as any sigma star followed by 00. Sigma star followed by 00. This is your regular expression. Okay, so anything followed by 00. At the end, I should have 00. So we have seen minimal NFA, we have seen minimal DFA, we have seen regular expression. All these 3 things we have seen in this question. Now let's move on. So you can notice this is your minimal NFA, this is a regular expression, and you can notice this is your DFA, minimal DFA. Now let's see the next question. Question number 4 from the Duke University. So let's see this. The question is asking, convert the NFA to DFA. This NFA is given to you. We need to convert this NFA to DFA. So let's do that. So tell me what will be the initial state. Take your copy pen. Please take your copy pen. Take your copy pen. What will be the initial state? We need to convert this NFA to DFA. This is NFA is given to you, and we need to convert this NFA to DFA. You tell me one thing. In this NFA, do we have null move? Do we have null move? Is there any null move? Yes, there are null moves. You can notice we have null move. So remember, this NFA contains null move. This NFA contains null moves. This NFA contains null moves. So when you null move, then you should be extra careful. Do you agree with me? Do you agree with me that when you have null moves, then you should be extra careful? Then you should be extra careful because there are null moves. So you should be extra careful. Okay, now let's see. What will be the initial state? Initial state will be the closure of this initial state. Null closure of this initial state. See, this is the simple point that if I convert NFA to DFA, if I convert this NFA to DFA using subset construction algorithm, if I use this algorithm, in this algorithm, you tell me what will be the initial state of DFA in this algorithm. In this algorithm, what will be the initial state of DFA? What will be the initial state of DFA? That will be the null closure of initial state of NFA. Okay, let's assume in this NFA, let's assume initial state is Q0. Let's assume this initial state was Q0. So tell me, what will be the initial state in DFA? that will be the null closure of epsilon closure of, that will be epsilon closure. Okay, that will be null closure, or I can say epsilon closure of Q0. Okay, so this will be your answer. So very simple. So you tell me what is the null closure of this one? What is the null closure? What is the null closure of epsilon closure of state 1? State 1. That will be 1 only. From this state 1 for free where I can go. Null closure, what it means? It means from this state 1 for free where I can go. If you are in this state 1 for free without reading any symbol, where can you go? From this state 1 without reading any symbol, without reading any alphabet symbol, without reading any alphabet symbol for free, where can you go? You can go to state 1. So this is the idea. So you can notice in the DFA, let's create the DFA. In the DFA, the initial state will be 1. So your initial state, we got it. The initial state, that is going to be 1. You tell me where this state will go on symbol A. Where this state will go on symbol A. How to find that? See, this state 1, where it will go on symbol A. How to find that? Tell me how to find that. Where this will go on symbol A, means this state 1 on symbol A, where it will go. How to find? So very simple. You will do like this. In this state 1, first you find the null closure, then you find on A where you will go, and then you find on null closure. Is this mandatory? I told you, do you remember? This step is redundant. This step is redundant. Do you remember? Anyone remembers? This is redundant, but not wrong. See, this is redundant. This is redundant. Remember, this is redundant. Not wrong. This is not wrong. Remember. Okay, you can do it. This is not wrong. Okay, this is not wrong. This is redundant. You can check it. Okay, so this is redundant when converting NFA to DFA. This is redundant when converting NFA to DFA. NFA to DFA. Tell me one thing. When you calculate the extended transition function, is this redundant? Is this redundant when you calculate extended transition function? Extended transition function. When you calculate extended transition function, is this redundant? No, this is not redundant. So please understand, this is redundant. This step, this first step, this is redundant only when converting NFA to DFA. This I told you, if you remember, only when converting NFA to DFA. So when you are converting NFA to DFA, in that situation, this is redundant, because anyway you will get the same. So remember, you can directly do this. On A where you will go, and then epsilon closure where you will go. Here what you will see? Here you will only see the edges. Yes or no? Here you will only see the edges. That's it. Okay. So from state 1, where are you going on symbol A? From state 1 on symbol A, this edge you have, only look at the edges. Only look at the edges. So you will go to state 2. Okay. So when you remember this point, in this state 1, if you read symbol A, where are you going? Just look at the edges. Just look at the edges. Means just look at the transition function. Just look at the transition function. Now you tell me, from state 2 for free, where you can go? From state 2 for free, where can you go? From state 2, you are in state 2, you are here. For free you can go to state 2. For free you can go to state 4. Yes or no? From state 2, remember, I can say, if you are in state 2 for free, this is your extended transition function. Extended transition function. Extended transition function. From state 2 for free, where you can go? You can go to state 2. You can also go to state 4. Okay. For free, you can go to state 2. For free, without reading any alphabet symbol, without reading A, B, you can go to state 4 also. So I can say that will be 2, 4. So very simple. This is the idea. From state 1, if you see symbol A, then you will go to 2, 4. Okay. Next, where you will go on symbol B? This state 1, where you will go on symbol B? This state 1, where it is going on symbol B? So that is going to 5. Yes or no? That is going to 5. Remember, you are going to 5. So very simple. In this state 1, if you read symbol B, then there is nowhere to go. There is nowhere to go. Means you are going to state 5. You are going to state 5. Then if you see this also, then also state 5. So ultimately you are going to state 5. So very simple point, that from this state on symbol B, you are going to state 5. 5 means dead. Yes or no? You are going to 5. 5 means your dead state. So that will be like this, A comma B. Okay. Next you tell me, from state 2 comma 4, this state is over. This state is done. Also this state is done. From state 2 comma 4 on a variable go. From state 2 comma 4 on a variable go. This is your state 2 comma 4 on symbol A, and then epsilon. So tell me, so where this state 2 will go on A? This state 2, where it will go on A? State 2, just look at the edges. Here, you just need to look at the edges. Just look at the edges. Edges only. Look at edges only. Okay, so you tell me, where this state 2 will go on A? So on A, this is not going anywhere. And where this 4 is going on A? Where this state 4 is going on A, it is going to 3. It is going to 3. So you tell me, this 3 for free, where it can go? If you are in state 3, if you are here, for free, where can you go? For free, you can go to 3 only. You can go to 3 only. So I can say that your final answer will be this. So 2 comma 4 on A, it will go to 3. 2 comma 4 on A, that will go to state 3. Where it will go on B? 2 comma 4 on B. You can check the diagram. 2 comma 4 on B. This 2 comma 4, where it will go on B, and then for epsilon. So you can notice that when you are looking this, just look at the edges. Just look at the edges only. Edges only. Just look at the edges. So 2 comma 4 on B. This state 2 on B. On B it is going to 3 also. On B it is going to 1 also. So it is going to 3 comma 1. Okay, so this is going to 3 comma 1. Next, so you can say, I can say 3 comma 1. Where this 4 is going on B? Where this state 4 is going on B? State 4, this state 4, it is going on B to 1. It is going to 1. So I can say it is going to 1. That is already here. Now you tell me, where 3 will go for free? 3 can go for free to 3 only. This state 3, for free it can go to 3 only. Where this 1 can go for free? This state 1, where it can go for free? It can go for free to 1 only. So your final answer will be 3, 1. So I can say that from this state on B, on symbol B, you will go to 1, 3. Like this you can do. From this state 3, where you will go on symbol A? State 3 on symbol A. On symbol A. And then null transition. So state 3 on symbol A, just look at the edges. Just look at the edges only. When you see this, just look at the edges only. So you will go to 3, and then for free you will go to 3. So I can say there is a self loop on symbol A. Where you will go on B, this is state 3, where it will go on symbol B. Again, you can notice when you see this, only look at the edges. Just look at the edges only, that's it. So where it will go, you can notice state 3 on symbol B, it will go to 5. It will go to 5. There is nowhere. Nowhere means that is your 5. So I can say that is your dead state. Means from this state on symbol B, you will go to 5 on symbol B. Like this you can do. Okay, very simple. This state is done. This state is done. Now this state 1, 3, where it will go? Now this state 1, 3 is remaining. 1, 3 on A, 1, 3 on B. So on A, where it will go? And on B, where it will go? On B, where it will go? So tell me, on A, where it will go? This state 1, just look at the edges. See here, just look at the transition function. Just look at the transition function. Just look at the edges means transition function. Only look at the transition function. So you tell me, this state 1 on A, where it is going? State 1 on A, it is going to 2. State 1 on A, it is going to 2. State 3 on A, state 3 on A, it is going to 3. Now where they are going for free? 2 is going for free to 2, 4. And 3 is going for free to 3. So 2, 3, 4. Okay, so from this state, you are getting 2, 3, 4 also. Okay, you are getting like this. On symbol A, you are going to 2, 3, 4. This is what you are getting. On symbol B, where you are going? 1, 3 on symbol B. 1, 3 on symbol B. They are going to 5. They are going to 5. So very simple. So the idea This is the idea that from this state, if you see symbol B, then you are basically going to, sorry, this state was already done. Sorry for that. It will be like this. From 1,3 on A, you are going here, and from 1,3 on B, you are going here. Yes or no? Correct? Agree? Okay. So this is the idea. So you can see from 1,3 on symbol A, you are going to 2, 3, 4. From 1,3 on symbol B, you are going to 5. So now this state is also done. So these states are done. Now 2, 3, 4 is still remaining. So where it will go on A? 2, 3, 4. That is remaining. 2, 3, 4. 2, 3, 4. Where it will go on symbol A? So tell me. And where it will go on symbol B? Let's quickly do. Just look at the edges. Only look at the edges. When you see this, just look at the edges. Just look at the edges only. That's it. Only look at the edges. So you can notice 2, 3, 4 on A. 2, 3, 4 on A. 2, 3, 4 on A. On A. 2 is not going anywhere. 4 is going to 3. 3 is going to 3. 4 is going to 3. 3 is going to 3. And 3 for free, it is going to 3. Next, 2, 3, 4 on B. So remember, this 2, 3, 4 on A, it is going to 3. This 2, 3, 4 on A. On A, it is going to, remember, on A, it is going to 3. Next, where they are going on B. So this 2, 3, 4 on B. This 2 on B, it is going to 1, 3. 1, 3. Yes or no? So they are going to 1, 3. Very simple. 1, 3. Where they are going for free? They are going for free to 1, 3 only. So I can say from this state on symbol B, you are going to 1, 3. This is your DFA. That's it. Now this state is also over. All the states are over. This is your final DFA that you will get. Tell me what will be the final state. What is going to be the final state? Here you can notice 4, 3 are final state. Yes or no? In the NFA, 4, 3 are final state. So your final state will be all the states which contain 3 or 4. Which contain 3 or 4. So this will be final state. 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 So these 4 will be final state. So this is your DFA. Did you understand? Please tell me. Please tell me, did you understand this? So this is the complete revision of NFA to DFA conversion. Yes or no? Complete revision of NFA to DFA conversion. NFA to DFA conversion. Tell me. Yes or no? Now let's see. Now let's move on. So this was the answer given in this university. This was the answer given, but that is not correct because this was missing. Yes or no? This was missing. This 5 was missing. Okay, so some transitions were missing. Remember, this answer was given, but some transitions were missing. Okay, some transitions were missing. You can check it out. But the point is, okay, forget about it. Forget about it. The point is this answer that we have created, that is correct. Okay, is this clear? Remember, this answer that we have created, this is correct. Is this point clear? Let me know. Is this point clear? So Kavya is saying that, सर आप तो सच्ची लाइव क्लास भी ऐसे लेते हैं कि किसी ने कुछ ना पढ़ा हो तो भी वो टीओसी में मास्टरी कर ले. थैंक यू काव्य, थैंक यू. So let's move on now. Now let's see this. Question number 5,6. This is Florida Institute of Technology. In short, it is called FIT. Okay, FIT. So now let's see. This is the question. 2 questions are there. This is the first question. Create NFA. So let's see this. Draw the NFA that recognizes the language W containing substring 0101. Okay, containing substring 0101. We need to create NFA. So can we do this? Containing substring 0101 means, remember anything can come here. See, initially anything can come. Initially anything can come. Then this should come. This should come. This must come. And then anything can come. Yes or no? And then anything can come. Agree with me? Containing substring 0101. So what will be the regular expression? Can anyone tell me what will be the regular expression? The regular expression will be sigma star 0101 sigma star. This will be the regular expression. Okay, now you tell me what will be the NFA. The NFA is very simple. In the initial state, anything can come, anything can come, anything. Then what should happen? Then 0 1 0 1 should come. Then what should happen? 0 1 0 1 should come. 0 1 0 1 should come, and then anything can come, and then anything can come. So this is your NFA. How many states? 5 states. So remember, minimal NFA has 5 states. This is your minimal NFA, and it has 5 states. It has 5 states. Is this point clear? So very simple. This is how you can create the NFA. And minimal NFA, this is your minimal NFA. Means what it means? If I say minimal NFA has 5 states, what it means? If I say minimal NFA has 5 states, what it means? It means there is no NFA with less than 5 states for this language. For this language, there is no NFA with less than 5 states. Is this point clear? Please tell me. If I say minimal NFA has 5 states, see, minimal NFA for L has 5 states. Has 5 states. What it means? Minimal NFA. So what it means? It means that there is no NFA. It means there is no NFA. There is no NFA with less than 5 states. With less than 5 states. With less than 5 states for L. Okay, so this is the meaning. This is the meaning. Means minimum, these many states we need. These many states we need, minimum. So this is the idea. Now let's see this one. The question is asking, convert this NFA to DFA. This NFA is given to you. We need to convert this NFA to DFA. So first what you will do? You will create the, tell me, what you can do? First you can create in this, first you can create the diagram. The diagram representation you can create for the NFA. For this NFA N, you can create the diagram representation. Okay, so because that is easier. Okay, so if you create the diagram representation, that will be easy for you. That will be very easy for you. Okay, so you can create the diagram representation and then you can convert to DFA. Can I give this question as a homework? See, on symbol A, where are you going? On symbol A, you can go to Q0. Let me create the NFA. Tell me what is the initial state here? Can anyone tell me what is the initial state here? What is the initial state here? See, the initial state, if nothing is given, then you can consider this as the initial state. Is this point clear? If nothing is given, this top state, this state in the first row, this you can consider as the initial state. Okay, this is the point. See, the purpose of this question is to convert NFA to DFA. That is the purpose. Yes or no? So don't worry about the final state. Do not worry about the final state. The purpose of the question is to convert NFA to DFA. This is the purpose. Just convert NFA to DFA using subset construction algorithm. Using subset construction algorithm. Using this algorithm, you convert NFA to DFA. Okay, very simple. Is this point clear? So you can see. First, you tell me how to create NFA. How to create NFA on Q0 from the initial state on symbol A, where you will go. On symbol A, where you will go. See, from state Q0 on symbol A, you will go to Q0, Q1. Means you will go to Q0 also. You will go to Q1 also. You will go to Q1 also. Okay, you will go to Q0 also. You will go to Q1 also. On symbol B, nowhere. On symbol B, nowhere. On null move, there is a null move to Q2. There is a null move to Q2. Okay, from here, there is a null move. There is a null move to Q2. Next, from Q1 on symbol A, from Q1, there is nowhere. On symbol B, you are going to Q1 also, and you are going to Q2 also. Next, you are going to Q1 also, you are going to Q2 also. What about the next? You can notice there is no null move from Q1. From state Q1, there is no null move. There is no null move. Tell me about Q2. Q2 on symbol A, it is going to Q2. Okay. There is no move on symbol B. And there is a null move to Q1. There is a null move to Q1. There is a null move. We have a null move. We have a null move to Q1. So this is the NFA that you have. Tell me, when you convert this NFA to DFA, what will be the initial state? What is going to be the initial state? The initial state will be the null closure of Q0. Yes or no? The initial state will be the null closure of Q0. So tell me what is that? Null closure of Q0. Null closure of Q0. From Q0, for free, where you can go? If you are in this state Q0, for free, where can you go? For free, you can go to Q0 also, you can go to Q2 also, you can go to Q1 also. You can go to, for free, where can you go? Please notice, from this state Q0, for free, where can you go? You can go to Q0. You are in state Q0. For free, you can go to Q0. For free, without reading any alphabet symbol, without reading A, B, for free, you can go to Q2 also. You can go to Q2 also. And notice that you can go to Q1 also. Because from Q2, without reading any symbol, you can go to Q1. Without reading any symbol, you can go to Q1. So I can say that null closure of Q0, that will be Q0, Q1, Q2. Please tell me, did you understand? From Q0, for free, you can go to these states. For free, you can go to all the states. So your initial state will be what? Your initial state will be Q0, Q1, Q2. This will be your initial state. From this state, where you will go on A, where you can go on symbol A. From this state, Q0, Q1, Q2. On symbol A, where can you go? On symbol A. So tell me, you can notice, just look at the edges. Just look at the edges. That's it. Only look at the edges. So tell me, on symbol A, Q0. This Q0 is going to Q0, Q1. This is going to Q0, Q1. Okay, next. This Q0 is going to Q0, Q1. Next, Q2 is going to Q2. Q2 is going to Q2. Okay, Q2 going to Q2. Q1 is going to nowhere. So I can say like this. Next, to tell me where they will go. For free. For free, they will go to Q1, Q2, Q0. Because you can notice that this Q0 for free it will go. You can notice this Q0 for free. For free, it will go to Q0, Q1, Q2. Okay, so this is the idea. So I can say that there will be a self loop. There will be a self loop. Tell me where you will go on symbol B. This state Q0, Q1, Q2 on symbol B. Where you will go on symbol B. Just look at the edges. Only look at the edges. So there is no edge on B from Q0. From Q0, there is no edge on B. There is no edge on symbol B. From Q1, on symbol B, you can go to Q1, you can go to Q2. Okay, you can go to Q1, Q2. Next, from this state on symbol B, you can go nowhere. So I can say Q1, Q2. Again, you can notice Q1, Q2 for free. Where can they go? For free, Q1 for free, it can go to Q1. Q1 for free, it can go to Q1. And Q2 for free, it can go to Q2, Q1. It can go to Q2, Q1. So ultimately, I can say Q1, Q2. So I can say, remember on symbol B, you are going to Q1, Q2. Okay. Now this state is over. What about this state? Q1, Q2. What about this state? Q1, Q2. Where it will go on symbol A? Where this will go on symbol A? This Q1, Q2. And where this will go on symbol B? Let's see. This Q1, Q2 on symbol A. Let's check it out. Q1, Q2 on symbol A. So you can notice this Q2 is going to A only. That's it. Okay. So this Q2 is going to this Q2 is going to Q2. This Q2 is going to Q2. That's it. Next, where this Q2 will go for free? This Q2 will go for free to Q2, Q1. This Q2, it will go for free. It will go to Q2 also. It will go to Q1 also. Okay, for free. So I can say your final answer is Q2, Q1. So that will be the self loop. Yes or no? That will be the self loop. On symbol A, there is a self loop. What about symbol B? What about symbol B? Q1, Q2 on symbol B. Q1, Q2 on symbol B, they will go to Q1, Q2 only. They will go to Q1, Q2. And then for free, where they can go? For free, they can go to Q1, Q2. For free, they can go to Q1, Q2. So your final answer, there will be self loop on B also. Now this state is also over. This is your DFA. This is the DFA that you will get. Is this point clear? Please tell me. Let me know. NFA to DFA conversion. If you convert this NFA, to DFA, you will get this DFA. So this is your final answer. Let me know, did you understand? So very simple. Kavya is saying that on B it is going to phi. Who is going to phi? Kavya. On symbol B, who is going to phi? Q1, Q2, on symbol B. Q1, Q2, Q1, Q2, on symbol B. Let's see. See this Q1 on B, it is going to Q1, Q2. Yes or no? Notice, Kavya. Q1, this state Q1 on B, it is going to Q1, Q2. So this state Q1 on symbol B, it is going to Q1, Q2. It is going to Q1, Q2. And from here, for free, you are going to Q1, Q2. So there is a self loop. Is this clear, Kavya? Please tell me. Let me know. So your final answer will be this only. This is your final answer. Okay. So very simple. Now let's move on. Now let's see question number 7. This is from Berkeley University. Now let's see this one. So some languages are given to you, A, B, C, D, E. We need to create DFA for these languages. We need to create DFA. So let's create minimal DFA for these languages. So let's see the first one. What the first one? The set of all 0, 1 strings that begin with 0 and with 1. So let's create the DFA for this language. Okay. What is the first language? Tell me what is the regular expression. Can anyone give me the regular expression? The language is this. The set of all 0, 1 strings that begin with 0 and end with 1. This is what we want. Begin with 0 and with 1. So you should begin with 0. Then anything can come. And then you should end with 1. Okay. This is the regular expression. Now you tell me how to create the DFA. Notice that in the initial state, if the first symbol is 1, where you will go? If the first symbol is 1. If the first symbol is 1, then dead state, because then hopeless situation. Yes or no? If the first symbol is 1, then hopeless situation. Because notice. If the first symbol is 1, then all the hope is gone. All the hope of acceptance is gone. Do you agree with me? Yes or no? If the first symbol is 1, now all the hope of acceptance gone. Then all hope of acceptance gone. There is no hope of acceptance now. This is the hopeless situation. If you start with 1, then there is a hopeless situation, because whatever I put here, whatever comes in future, I can say I cannot accept. So all hope of acceptance is gone. So very simple. Now you tell me, if the first symbol is 0, then what I will do? Now I have seen 0. Now I want to end with 1. Remember, I have seen 0. I am waiting for 1. Agree with me? I have seen 0. I have already seen 0. This first 0 I have seen. Now I am waiting for 1. Okay. In this state, if symbol 1 comes, I will be very happy. In this state, you tell me, in this state, I have seen 0. I am waiting for 1. If 0 comes, what I will do? Tell me, in this state, I have already seen 0. This 0 I have already seen. This 0 I have already seen. Now, if another 0 comes, no problem. If another 0 comes, no problem. I will wait for 1. If another 0 comes, no problem. I will ignore. I can ignore. I will wait for 1. In this state, if 1 comes, in this state, I have ended with 1. Now, in this state, if 1 comes, no problem. If 0 comes, what I will do? In this state, if 0 comes, I will wait for 1. So this is your DFA. Yes or no? This is the minimal DFA. How many states? In the minimal DFA, how many states? So there are 4 states in the minimal DFA. This is your DFA for this language. So this language A is done. Okay, we have done it. What about the next one? Okay, so here you have not A, B, but here you have 0, 1, no problem. The alphabet is 0, 1. So this will be 0, 1. Okay, now let's see the next one. The next one is sigma is A, B. L is any string not in A star, B star. How to do this? Tell me how to do this. L is any string not in A star, B star. This is what we want. For B, basically our language is what in option B? I can say A star B star complement. Yes or no? Agree with me? A star B star complement. Complement of A star B star. Do you agree? This is the language. Our language is A star B star complement. This is our language. So what you can do? I want to create DFA for this. I want to create DFA for this. So what I can do? DFA for complement of A star B star. DFA for complement of A star B star. So how to do that? Tell me. This DFA I want to create. How to do? This is what I can do. See, I can take DFA for A star B star. I can take DFA for A star B star, and then I can complement the states. Okay, then I can complement the states. All the final states I will make them non-final. All the final states I will make them non-final states, and all the non-final states I will make them final. So very simple. This is the idea. Yes or no? Agree with me? See this question. L is any string not in A star B star. Not in A star B star. The question is saying not in A star B star. Means the complement of A star B star. I want to create DFA for complement of A star B star. So what I can do? I can create DFA for A star B star. Then I can complement the states. Then I can make all the final states, I can make them non-final. All the non-final states, I can make them final. This is what I can do. Okay, so let's create the DFA for A star B star. So let's create DFA for A star B star. So tell me how to do this. A star B star. This simply means after B, A cannot come. Yes or no? Agree with me? Do you agree with me that after B, A cannot come? After B, A cannot come. This is your A star B star. After B, A cannot come. So you tell me, in the initial state, should I make it final state? The initial state, should it be final state? Yes, because in the DFA, you want to accept empty string. Yes or no? Because I am creating a DFA and I want to accept empty string. This point you already know that DFA accepts empty string if and only if. DFA accepts empty string if and only if initial state is final. Yes or no? This point we already know. If and only if initial state is final. Agree with me? This point. In our lectures, we have seen this point that DFA accepts empty string if and only if initial state is final. So I want to accept empty string. So this initial state will be final. In this state, if A's are coming, is there any problem? Is there any problem? There is no problem. You can accept A's. This string you can accept. This string you can accept. This string you can accept. There is no problem. In this language, you can notice in this language, this string is accepted. This string accepted. This string accepted. You can accept this string also. You can accept this string also. You can accept this string also. So these are the strings that you are accepting in this language. Okay, very simple. You can also accept AA, BB. This is also accepted. So very simple. Now you can notice if A's are coming, no problem, no problem. If B is coming, I will accept. If B is coming, because you can notice these strings I need to accept. Yes or no? I need to accept. For example, this string should be accepted. This string should be accepted. This string should be accepted. So these strings should be accepted. Now in this state, if B's are coming, I should accept. Okay, I should accept. Now you tell me, in this state is over. In this state, on symbol A, what to do? On symbol B, what to do? That is over. In this state, is this the DFA? Did I get the DFA? Tell me, is this the DFA? Is this the DFA? No, this is not the DFA. Because in this state, what to do on symbol A? Tell me what to do on symbol A. In this state, after B, if you see symbol A, after B, if you see symbol A, then all the hope is gone. Dead state. All the hope is gone. All the hope is gone. Yes or no? Because remember, look at the language. Your language is A star, B star. This is your language. So in this language, after B, A cannot come. After B, A cannot come. After B, A cannot come. So remember, after B, if A is coming, then all the hope of acceptance gone. All the hope of acceptance has gone. This is the hopeless situation. So you can go to dead state. This is your DFA. Please tell me, did you understand? So there are two final states and there are total 3 states. So minimal DFA has how many states? There are 3 states in the minimal DFA where 2 states are final. Where 2 states are final. There are 2 final states. So this is your minimal DFA. But you can see in the question what is asking. What the question is asking, tell me. What the question is asking. The question is asking DFA for complement of A star B star. DFA for complement of A star B star. Yes or no? The question, if you notice, question number B is asking DFA for complement of A star B star. This is your A star B star. We want complement of this. This is what we want. Complement of A star B star. This is what we want. So tell me what to do. Tell me what to do. DFA for this. Very simple. All the final states will become non-final. All the final state. This final state, you will make it non-final. You will make it non-final. This final state also you will make it non-final. This final state also will become non-final. And this final state will become final. This non-final will become final. This non-final state, it will become final. Now, this is the correct DFA. So what your answer will be? So I can say that for this language, I can say 3 states in minimal DFA. Minimal DFA will have how many states? Minimal DFA will have 3 states and there is only one final state. There is only one final state. So this is your answer. I hope this point is clear. So very simple. Now let's see the next one. The set of strings over the English alphabet where third last letter is B. This is a standard language. Yes or no? This language is standard language. Do you remember? Third last letter is B. So what are the number of states here? This is your C. This is a standard language basically. Your alphabet is English alphabet. What is your alphabet? That is English alphabet. Your English alphabet means this A, B, C, D and so on Z. So this is your alphabet. The question is asking that third last letter is B. Okay, so this is what we want. So I can say this is your language. Your language is, this is your language that anything can come here, but this letter is B. Then one symbol can come here, one symbol can come here. Okay, so very simple. Here anything can come. Here anything can come. That means sigma star. So tell me what will be the regular expression? Can you tell me? Can you tell me the regular expression? Regular expression is anything can come. Sigma star, anything can come. Then this third letter from right. Remember from the end. The third last letter is B. The third letter from the end, that is B. Okay, after this, 2 symbols can come. This will be your regular expression. Now you tell me. This is the standard language that we have seen. Yes or no? For this language, complete analysis we have seen in the class. The complete analysis of this language, complete analysis, we have already done in class. Already done in our lectures. The complete analysis I told you, if you remember. So tell me, what will be the number of states for this? For this language L, what will be the number of states? For this language L, sigma star, B, sigma, sigma. Third letter from right is B. Okay, your sigma is A, B, C, and so on Z. This is your sigma. So you tell me, for this language, what will be the, in the DFA, in the minimal DFA, how many states will be there? In the minimum DFA, tell me. Here you have third letter from right is B. Basically, this means third letter from right is B. So tell me how many states? How many states will be there? Tell me how many states will be there? There will be 2 power 3 states will be there. There will be total 8 states will be there. And there will be half of them will be the final states. Yes or no? Half of them will be final states. Final states will be half of them. Half of them. So total 8 states will be there and total 4 final states will be there. So this is your minimal DFA. So remember this point that complete analysis of this language. For this language, the complete analysis we have already done in our class, in our lectures. So you can check it out. We have already done the complete analysis. Now let's move on. Now let's see the next question. The next question. This is quite interesting. This is very interesting question. See this. The question is saying that sigma equal to A, B. This is your alphabet. L is set of all strings with odd number of A's, with odd number of A's and even number of B's and doesn't contain BA as a substring. What this line means? Please tell me. Please tell me what this line means. What this line means. What this line means. I'm only interested in this line. You just tell me what this line means. Doesn't contain BA, then what it means? Doesn't contain BA. It means that your language is subset of A star, B star. Agree with me? See, doesn't contain BA. After B, A cannot come. Doesn't contain BA means after B, A cannot come. A cannot come. After B, A cannot come. So please understand that what this means. If I say doesn't contain BA, doesn't contain BA, doesn't contain BA substring, BA substring. What this means? This is very interesting. This is very important that if you do not contain BA, then what type of strings you can create? Just tell me this point. I want to ask what type of strings you can create. What type of strings? What type of strings we can create? We can create. You tell me this point. Doesn't contain BA. I don't want to contain BA. I don't want to contain BA. Then what type of strings I can create? Tell me. See, after B, if A's are coming, is there any problem? If A's are coming, is there any problem? If A's are coming, is there any problem? There is no problem. There is no problem. If A's are coming, there is no problem. Tell me. When the B will come, let's assume this is the first B. Let's assume this is the first B. Now you tell me, is it possible A can come? Is it possible A can come? Is it possible A can come? A cannot come. A cannot come. If A cannot come, then who will come? If A cannot come, then who can come? B's can come. So can you notice this language? Remember, this is quite important. Does not contain BA substring. Does not contain BA substring. That is same as A star, B star. Yes or no? Yes or no? That is same as A star, B star. Okay. So now you tell me what is this language? Option D. In the option D, what language you have? So if you notice option D, this option D has this type of language that basically this point is clear that we want odd number of A. In option D, we want odd number of A's. Odd number of A. We want even number of B's. This is what we want, even number of B's. We also want not containing BA. This is also we want not containing BA. So now you tell me from these three. From this you can see that it will be some type, this type of string will be there. A star, B star type of string. Yes or no? This type of string will be there. This type of strings not containing BA. And what also we want? We want odd number of A and even number of B. So tell me finally what your language is. Finally, if you include all these, then finally what your language is? Your language is A power odd, B power even. This is your language. Do you agree with me? Please tell me. Your final language, this is your language of option D. This is your language of option D. So please tell me, did you understand this language? Do you agree with me that in option D, your language is A power odd, B power even. This is your language. Let me know, did you understand? This is very beautiful question. This option D. This is a beautiful question. First, you have to understand this question. Okay. So I can also say the regular expression. How to write that? How to write regular expression? You want odd number of A's. So I can say odd number of A's. That means like this. This is your odd number of A's. Because this is even number of A's. See, notice this is even number of A's. So odd number of A's, this will be odd number of A's. Next, you can notice even number of B's. This is the regular expression. Can you create DFA? Now, can you create DFA? So very easily, this is your initial state. Is it possible? Should I make it final state? Should I make it final state? Please tell me. Should I make it final state? Let me know. In this language, what strings are there? See, in this language, empty string is not there. Can I create this string? Can I create this string? This string is also not there. There should be at least one A. Yes, this string I can create. This string also I can create. This string also I can create. This string also I can create. So please notice this string BB, this string also I can create. So this is your language. So you can notice empty string is not accepted. So initial state is not final. So initial state is not final. This is your initial state. In this initial state, we must have at least one A. At least one A we must have. Now here we have odd number of A's. Okay, here we have odd number of A's. We must have at least one A. In this initial state, if symbol B comes, if the first symbol is B, what should I do? If the first symbol is B, what should I do? I should go to dead state because all the hope of acceptance is gone. This is hopeless situation. All hope of acceptance gone. Now you tell me in this state I want, in this state now I want even number of A's. Okay, now I want even number of A's, means I can say that this type of thing we want, because ultimately I want odd number of A's. So remember, in this state, I already have odd number of A's. In this state, I already have odd number of A's. Okay, so if more A's are coming, then how many more A's should come? Means this A has already come. See, this A has already come. This A has already come. This A has already come. Okay, now how many more A's we want? Tell me how many more A's we want? Even number of, yes or no? How many more A's we want? Even number of A's we want. Now, you tell me one thing. Here you have even number of A's. After even number of A's, if B comes, where you will go? After even number of A's, if B comes, then it means dead state. Yes or no? Then dead state. After even number of A's, if B comes, then it means you are going to dead state. All the hope of acceptance gone. Okay. Now this state is over. This state over. This state over. Is this the DFA? Is this the DFA? No. In this state, what to do when B comes? In this state, if B comes, where you will go? Where you will go? In this state, if B comes, now how many B's I have? Tell me. How many B's I have? I have odd number of B's. Yes or no? I have odd number of B's. But I want even number of B's. I want even number of B's. So I can create like this. I want even number of B's. Okay, so very simple. This is the idea. So tell me, how many final states will be there? See, this also will be final state. This also will be final state because this A star should be, A plus should be accepted. Remember, A plus should be accepted. This type of strings should be accepted. This type of strings, A, 5A, this should be accepted. Okay, so remember this 5A, this should be accepted. So I can say that this also will be the final state and this also will be the final state. Is this minimal DFA? Please tell me. On your screen, we got the DFA. DFA we got. Yes. Okay. Yes or no? DFA we got. We got the DFA. We got the DFA. But is this minimal? We have found the DFA. First of all, you tell me, forget about minimal. Forget about minimal. First you tell me, is this correct? Is this correct? Did you understand this? Did you understand this? First you tell me this point. Did you understand this? Did you understand this point? Let me know. Did you understand this point? So yes, this DFA we got. Is this minimal DFA? Is this minimal DFA? That is the question. Now, you can notice that Satyam is saying that we can combine start state and even A state. Can we do that? Satyam is saying we can combine start state and even A state. This even number of A, this state we can combine. Yes, we can combine that. That is a good idea. Okay, we can combine that. We can combine that. See what I'm saying? Let's see if this is minimal DFA or not. This DFA you understood, right? Okay, one by one, don't worry. This DFA you understood, correct? This DFA you understood. Now you have these states. I can say, for example, state P, state Q, state R, state S, state T. You tell me which of them are equivalent. So with state Q, which two you will compare? First you tell me, with this state Q, which state you will compare? Which state you will compare? Now let's do the minimization. Let's do the minimization of DFA. let's do the minimization of DFA with this state Q. With this state Q, which state you will compare? You will compare state T. Okay, so let's compare them. Let's compare them. State Q comma T, are they equivalent? State Q comma T, are they equivalent? Are they equivalent? State Q comma T. Tell me, are they equivalent? State Q comma T. State Q comma T. Are they equivalent? Please tell me. Focus here and tell me. Are they equivalent? See, they are not equivalent. Why they are not equivalent? Can anyone tell me? They are distinguishable by whom? They are distinguishable by whom? See, one more thing. In this state T, if A comes, where you will go? In this state T, if A comes, you will go to dead state. If A comes, you will go to dead state. In this state S also, if A comes, you will go to dead state. Okay, because after B, if A comes, you will go to dead state. After B, if A comes, you will go to dead state. So remember this point, that in this state, if A comes, you will go to dead state. And in this state, if A comes, you will go to dead state. Okay, so this is the point. Now, anyway, so let's see. Are they distinguishable? Yes, they are distinguishable. Remember, Q is not equivalent to T. Distinguishable by whom? Distinguishable by A. You can double A. Distinguishable by double A. They are distinguishable by double A. You can notice this state Q on double A, it is going to final. Yes or no? This state Q on double A, it is going to final. This state T on double A, it is going to non-final. So very simple. This state Q on double A, this state Q is going to final and this state T is going to non-final. So very easily you can notice they are not equivalent. So we cannot merge. Q comma T, we cannot merge. What about the remaining states? Is there any state which is equivalent to the dead state? Will you compare with dead state? Will you compare any state with the dead state? No, don't compare. Don't compare. Okay? Do not compare. Because these states, these three states, they will not be equivalent to dead state. Okay? These states, PSR, these states, PSR, these states will not be equivalent to dead state. So don't compare with the dead state. Now you have to compare which state? Tell me. Which state you have to compare? Tell me. P comma R. Yes or no? These two states, P comma R. So let's compare P comma R. Where are they going? This state P, is this equivalent to R? You tell me. But before that, you tell me, is this equivalent to S? P comma S. You compare P comma S. Tell me, are they equivalent? P comma S. They are not equivalent. Distinguishable by B. Yes or no? They are distinguishable by B. So you can easily notice P comma S, they are not equivalent. P is not equivalent to S. They are distinguishable by whom? They are distinguishable by B. Okay, you can easily notice because this state P on symbol B, it is going to non-final, and this state S on symbol B, it is going to final. So I can say they are different. You cannot merge P comma S. Now let's see P comma R. Okay, what about R comma S? Tell me about R comma S also. R comma S. They are distinguishable by A. You can notice R comma S. They are distinguishable by A. They are distinguishable by A. Okay, very easily you can see. Now let's compare P comma R. Okay, that can be interesting. P comma R. So let's see this P comma R. So where they are going? So you can notice here on symbol A, P comma R both are going to Q. Can you notice? P comma R? See, this state P, this state R. On symbol A, where are they going? Tell me, where are they going on symbol A? They are meeting. These two friends, this P comma R, these two friends, they meet. When they see on symbol A, they are meeting in state Q. Okay, let's assume in Delhi they are meeting. Okay, they are meeting in Delhi. Let's assume this is Delhi. Now what will happen? They are meeting at state Q. Now whatever string comes, they will always go together. Yes or no? Okay, yes or no? Because remember P comma R on symbol A, they are meeting in Delhi. Now they are meeting in Q. Now whatever string comes, they will always go together. Final together, non-final together. These two people. So what it means, let me tell you what this diagram means. This diagram means that P comma R, these two people, on this type of strings, they will always go together, either final or non-final. Is this point clear? They will always go together, either final on this a comma w, on this string w, on this string, either they will go to final, either you will have this entry, or you will have this entry, non-final. The point is they will always go together. So you can notice there is no problem here. What about B? What about symbol B? Tell me, what about symbol B? P comma R on symbol B. This state P, this state R on symbol B. They are going to dead state. Again, they are meeting in dead state. On symbol B, they are going to jail. Yes or no? See, they are going to jail. They are going to the dead state. On symbol B, they are going to dead state. Means on symbol B, they are meeting in jail. On symbol B, they are meeting in this state. Now, whatever comes, they will be together. So what I'm saying that this state P, this state R, on this type of strings, again, they will be together. Either final, or non-final. But the point is they will be together. Okay, they will be together. Okay, so very simple. I hope this idea is clear. Actually, they will be non-final because they are going to dead state. So they will always be non-final. So anyway, the point is that on all strings, they are going together. So I can say P is equivalent to R. This is the final conclusion. P is equivalent to R. So your minimal DFA will have how many states? So we can merge. So P comma R, these two states we can merge. Can be merged. We can merge these two states. We can merge them. Okay, these two states, we can merge them. Very simple. Yes or no? So if you merge these two states, so minimal DFA will have how many states? So minimal DFA has how many states? You can check. These two states you can merge. You can merge P comma R. So these are one state. Two state, and so there will be 5 states. So I can say if you merge them, then minimal DFA will have total 5 states. Okay, so very simple. I hope this point is clear. Is this clear? So minimal DFA will have 5 states because you can merge P comma R. This is your answer. Let me know, did you understand this? Please tell me. So we have done this one. The last one, can I give you as a homework? Please tell me. The set of all 0-1 strings that contain at least 2 zeros and at most 1 1. Okay, at least 2 zeros and at most 1 1. See, this language is also very simple. If you want to do, either you can apply the product automata. See, if you want, you can apply product automata if you want, but you can also apply the idea. Okay, let me do this. See, either you can apply product automata. What you can do, you can apply the product automata. You can create DFA for this, you can create DFA for this, and then you can apply the product construction. Is this point clear? What is the method number 1? What is the method number 1? Method number 1 is you create DFA. You create DFA D1 for this language, at least 2 zeros language. Okay, for at least 2 0 for this language, for at least 2 zeros. For at least 2 zeros. For this language, you create DFA D1. And you can create DFA D2 for this language. For which language? For at most 1 1. And then what you can do? You can create product construction. You can create product construction. Okay, so then you can find out. What is method number 2? Now let me tell you. What is the method number 2? For this language E, what is the method 2? That is analyze. Method 2. See, just notice what we need to keep track of. Just notice. Remember, your language is this. Your language is at least 2 A's and at most 1, at least 2 zeros. Okay, or let me take A's. A's means zeros, and at most 1 B. This is your language. Yes or no? Agree with me? You tell me, in this language, what you need to keep track of? In any string, what you will keep track of? Tell me. in any string, what you will keep track of? You will keep track of number of A's. Also, you will keep track of number of B's. Agree with me? You will keep track of number of A's and B's. Number of A's and B's. Do you agree? So far, do you agree with me that you will keep track of number of A's and B's? Now you tell me. For number of A's, what criteria are there? Which things you will keep track? For number of A's, what matters? When you count number of A's, what matters? When you are counting number of A's, what matters to you? Which categories you will create? See, either number of A's can be 0, or number of A's can be 1, or number of A's can be greater than or equal to 2. Can you notice? Will you create infinite categories? 3, 4, 5, 6, and so on. Will you create infinite categories? 3, 4, 5, and so on. No, there is no need. Because anything which is greater than equal to 2, that is in this category. So far, do you agree with me? So far, do you agree that anything in this category, that is one category? Yes or no? So number of A can be 0, or number of A can be 1, or number of A can be greater than or equal to 2. Yes or no? Please tell me. Is this clear so far? So these are the categories. For number of B's, what you will keep track of? For number of B's, what are the categories you need? For number of B's, what are the categories you can create? You can create 0B, or either there can be 0B or there can be 1B. Either there can be 0B or there can be 1B, or there can be anything greater than equal to 2. Yes or no? Agree? Because remember, either you can have 0 or you can have 1, or anything greater than equal to 2, that is not acceptable. Agree with me? This is not acceptable. This leads to dead state. Do you agree with me? This leads to dead state. Please tell me. This method 2 is simple analysis. See, this is your method 2. We are just analyzing. We are understanding and we are analyzing. Please tell me, so far, is this analysis clear? Remember, this is your language. Your language is at least 2 A's. You must have at least 2 A's and at most 1 B. This is your language. So you just, what you will keep track of? In any string, whatever string I give to you some string. What you will see in that string? You will keep track of number of A's and number of B's. Number of A's. In the number of A's, what are the categories you can create? You can create 0A, 1A, or greater than equal to 2A. These 3 categories you can create. If number of A's is greater than equal to 2, you can put in one category. Yes or no? If your number of A's is 2, 3, 4, 5, then you can put it in one category. Similarly, for number of B's, how many categories? Either you can have 0B, or you can have 1B, or you can have greater than equal to 2B. If number of B is greater than equal to 2, if number of B that is greater than equal to 2, that will lead to dead state. Please tell me, idea is clear? Let me know, idea is clear or not? This analysis we are doing, this analysis will improve your knowledge. Remember this point. See, this product automata, will you apply your mind here? Are you applying your brain in this method number 1? When you apply the product automata, are you doing the analysis? When you apply the product automata, you are not doing the analysis. Okay. But you can notice here you are doing the analysis. In this method number 2, you are thinking, you are running your brain, you are making your brain work. So this is the benefit of analysis. Now you tell me. So now let's create the DFA. Now let me create the DFA. So ultimately this is the language you want. So let's create the DFA. Initial state. What name you will give to the initial state? Tell me. What name you will give to the initial state? Initial state is the state of 0A and 0B. Can I say? Initial state is the state of 0A and 0B. This is the state of 0A, 0B. Do I want it? Is this final? At the end, we will see final. At the end, we will see at the end. What is final? We will see at the end. Okay. Anyway, this is your initial state. Initial state is 0A, 0B. Now, you can notice If A comes, then which state I will go? If A comes, I will go to 1A, 0B state. Yes or no? If another A comes, which state I will go? I will go to which category? Please tell me. In this state, if A comes, I will go to which category? See, there are three categories. Please understand, there are three categories from A point of view. From A point of view, there are three categories: 0A, 1A, or greater than or equal to 2A. Yes or no? From A point of view, there are three categories. Please understand that from A point of view, from A point of view, there are three categories. From A point of view. From A's point of view, there are three categories. We have three categories. What are three categories? The three categories are 0A, 1A, or greater than or equal to 2A. These are the three categories. Yes or no? So I can say that this is the idea, 0B. Okay, now tell me. So in this state, if B comes, where I will go? In this state, okay, one more thing. In this state, if A comes, where I will go? In this state. In this state, if A comes, where I will go? If A comes, I will go to greater than or equal to A, greater than or equal to 2. Yes or no? Because this is the category. This is the category, greater than or equal to 2. Can you notice this category division? This is beneficial, right? Very easily you can create the DFA. Very easily you can create the DFA. This category division. Did you understand this? If you understood this, then DFA creation is very simple. Please tell me, did you understand this analysis? This analysis, did you understand? Please tell me. If you understood this, then you can easily create the DFA. So you can notice in this state, if A comes, then that will be self-loop. Very good, very good. In this state, if B comes, where will you go? In this state, if B comes, where will you go? In this state, if B comes, you will go to 0A, 1B state. You will go to 0A, 1B state. In this state, if B comes, now remember this state is over. This state is over. In this state, if B comes, where will you go? In this state, if B comes, you will go to 1A, 1B state. 1A, 1B state. In this state, if B comes, where will you go? In this state, if B comes, where will you go? Greater than or equal to 2A and 1B. Okay, yes or no? Very simple. Very simple. You tell me one thing. In this state, remember this state is done. This state is done. In this state, if B comes, where will you go? In this state, if B comes, where will you go? If B comes, where will you go? Remember this point, that from B's point of view, what is happening? You tell me. From B's point of view, what is happening? Either you have 0B, or 1B, or you have more than or equal to 2B. You tell me, this will lead to dead state. Yes or no? Do you agree with me? See, this is fine. This is fine. This is fine. Because we want at most 1B. This is what we want. We want at most 1B. So I can say this leads to dead state. Correct? This leads to dead state. Okay, so I can say that if B comes, in this state, if B comes, then you are going to dead state. You are going to dead state. In this state, if B comes, you are going to dead state. In this state, if B comes, you are going to dead state. Isn't it simple? Okay, this is your DFA. Is this DFA over? Is this the DFA? No. In this state, if A comes, where will you go? In this state, if A comes, where are you going? In this state, if A comes, you are going to 1A, 1B. In this state, if A comes, you are going to this state. Now, this is over. This state is over. In this state, if A comes, where will you go? In this state, if A comes, you will go to self loop. Now you can notice this state is over. This state is over. All the states are over. This is your DFA. Tell me the final states. This is the DFA you got. This is the DFA. Tell me the final states. Tell me what are the final states. Remember, we want more than 2A, at most 1B. We want more than 2A, greater than or equal to 2A. This is the final state. So I can say your final state will be, this will be final. Notice this will be final. This will be final. These two states will be final. That's it. Yes or no? These two states will be final. Is this minimal DFA? Is this DFA minimal? We have created the DFA, but let's check, is this minimal? Can you check it out? Is this minimal? You check the final states. The two final states, are they minimal? The two final states, are they minimal? Please tell me. The two final states, are they minimal? Let's call it P, let's call it Q, let's call it R, let's call it S, T, V. Now tell me, the two final states, are they equivalent? The two final states, can I merge them? Are they equivalent? They are distinguishable by whom? They are distinguishable by B. Yes or no? So these two people are distinguishable by B. These two people, they are distinguishable by B. So I cannot merge. I cannot merge. So remember, these two people, they are distinguishable by B. I can say this R comma V, they are not equivalent, and they are distinguishable by string B. Okay. What about, will you compare with dead state? Will you compare any state with the dead state? Will you compare? No, there is no need to compare. What is the reason? Tell me, this state S comma dead state, why they are distinguishable? These two states, are they distinguishable? These two states are distinguishable by whom? Distinguishable by whom? S comma dead. These two, they are distinguishable by double A. They are distinguishable by double A. They are distinguishable by double A, because this will go on double A, it will go to final. On double A, it will go to final, but on double A, it will go to non-final. So they are distinguishable by double A. They are distinguishable by double A, because remember, S comma dead state, remember this point, on double A, this S is going to final, this dead state is going to non-final. Okay, very simple. This is the idea. Now you tell me the next. What about P comma Q? They are distinguishable by A. Yes or no? P comma Q. You can notice P is not equivalent to Q. Distinguishable by A. Correct? Distinguishable by A. P comma Q. They are distinguishable by A, because Q is going to final. On symbol A, Q is going to final. And on string A, this P is going to non-final. So can you notice, if you compare any two states, in these two four states, if you compare any of them, they will be non-equivalent. Yes or no? They will be not equivalent. These four, P, Q, S, T, they are not equivalent to each other. So you can easily notice P, Q, S, T, they are also not equivalent. You can easily check. So this is minimal DFA. So this will be minimal DFA. Remember, this DFA we have created, this is minimal DFA. Is this point clear? So this DFA that we have created, this is minimal DFA. This is minimal DFA. The DFA that we have created is minimal DFA. Okay, so this is your analysis. This is the complete analysis that we have seen. So please tell me, did you understand everything? So we have seen the DFA for all of them. So here the minimal DFA will have how many states? Minimal DFA will have, there will be 7 states. Minimal DFA has 7 states here. Okay, so these are some good questions. Yes or no? Some beautiful questions. Do you agree? For example, this question was good. You can notice this question was nice question. It was a good question. So I can say, if you notice the good questions, this was a good question, and the part D also was a good question. These two were actually good question. This option D, question number D, question number E, these are good questions. You can check. Okay, so like this you can do. Very simple. Okay, I hope this point is clear. So this is the complete analysis so far. Now we need to see more questions. Question number 8 to 10, Berkeley University questions. So these two questions also we need to see, and we will see all these questions in the next session. So anyone has any doubt so far? So far, anyone has any doubt? Let's discuss. If you have any doubt, we can discuss. So Kavi is sending one image, but Kavi, right now I cannot see that. Okay. So Kavi, what you can do, you can send it in the group, you can send it and we can discuss. Okay. Yes or no? So you have already created a solution. Some solution you have created. We can discuss it in the group, in the private group, we can discuss. You can tag me. Okay. Do you have any doubt that you want to ask in this session? Because the photo that you are sending, I will have to go through that photo. I will have to see your solution. I will have to think about it. Okay, I will have to find the mistake in the solution, or maybe the solution is correct. Okay, so it is a long process. So we can do that on the GoClasses private group. You can send your doubt in the private group, and you can tag me. Okay, you can tag me. Kavya is saying, what is the approach? Kavya, what is the approach? Can you suggest? Like right now, I cannot see the photo. Can you speak, and you can let me know what is your approach? Or just on the private group, you tag me, you send this photo, I will see. Okay, I will go through it and I will tell you what is the mistake. Don't worry. Hello, Kavya?
Yes, yes. Hello, sir. Am I audible?
Yes, audible.
Hello, sir, am I audible?
Yes, yes.
Yeah. Sir, actually in this question, sir, मतलब मैंने odd और even odd number of A's and even number of B's के लिए सर मतलब directly DFA बना लिया था 4 states का. And then जो दूसरी language थी, that does not contain substring BA. तो मुझे सर ये चीज strike नहीं करी कि वो मतलब A star B star ही है. So that is why I constructed a DFA for containing substring B and then I took the complement of it. और फिर सर वो D1 क्रॉस D2 कॉम्प्लीमेंट का सर मैंने वो पैरेलल में चला के मतलब प्रोडक्ट ऑटोमेटा बनाया सर.
देखो क्वेश्चन नंबर डी की बात हो रही है ना?
यस 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 सर.
ओके, तो क्वेश्चन नंबर डी के अंदर आपने क्या किया है? फर्स्ट यू हैव क्रिएटेड डीएफए फॉर कंटेनिंग बीए. First, you have created DFA for containing BA.
Yes,
then
sir.
you have created complement. So basically, you have created DFA for not containing BA. Okay.
Yes, sir.
So you got one DFA for not containing BA. You got
Yes,
this
sir.
this DFA you got. Let's call it D3. Then you
Yes,
have
sir.
created another DFA for what? Which language?
Sir, odd number of A's and even number of
Yes.
B's.
You have created one DFA for odd number of A's, and even number of B's.
Even number of B's.
Okay.
Yes.
Now what you need to do? You need to create the product automata and you need to
Yes,
find
sir.
the intersection. You need to find
Yes,
the
sir.
intersection. So you need to create product construction. This is what you need to do.
Yes, sir.
You need to create the product construction for intersection of these two, for intersection of D3 and D1. Okay. So like that, if you have done, then your answer is definitely correct.
Yes, sir.
Okay. Your approach is correct.
But
you want to
sir,
know that your approach is correct or not?
Okay.
Your approach is definitely correct because you have created DFA for not containing BA. You have created DFA for this. Ultimately, we want intersection of these two. Ultimately,
Yes,
we
sir.
want intersection of these two. So you create the product automata for intersection of these two. Okay.
यस यस ये क्या सर. ऑल्सो एक चीज और पूछनी थी. जैसे सर जब प्रोडक्ट कंस्ट्रक्शन करते हैं तो उसमें 3 स्टेट्स फाइनल है और जब मैं प्रोडक्ट मतलब जो डिजाइन कर रहा हूँ डीएफए तो उसमें हर स्टेट में सिर्फ 2 स्टेट्स यूज हो रही है. तो फॉर एग्जांपल मान लीजिए ए बी सी अगर फाइनल स्टेट्स हैं और मेरे पास जो डीएफए उसमें एक स्टेट में बीसी है एक स्टेट में ए बी है तो वो काउंट होंगे फाइनल में या फिर इंटरसेक्शन 5 कंसीडर होगा सर?
इंटरसेक्शन के लिए अगर आप प्रोडक्ट कंस्ट्रक्शन कर रहे हो इंटरसेक्शन के लिए तो सिंपल सा है. जैसे मान लो कि आपके पास एक डीएफए है डी, एक डीएफए है डी, एक डीएफए है D1, एक डीएफए है D2 और आप प्रोडक्ट कंस्ट्रक्शन कर रहे हो इंटरसेक्शन के लिए. ओके, यू आर क्रिएटिंग अ प्रोडक्ट ऑटोमेटा. Okay, product this D1 intersection D2, this construction you are doing. Now in this construction, what will be the final states? What will be the final states? So that will be those states. Remember, in this construction, those states will be final. Where basically in every state you have 2 components, right? Yes or no? One component is coming from D1, one component is coming from D1. This P, this is a state of D1, this is a state of D1, and this Q, okay, or I can say this R is a state of D2. Okay, now now what will be the final state in this construction? In this, because you are creating for intersection, so final state, this PR will be final. I can say final state, this PR will be final if and only if P is final in D1, R is final in D2. So remember,
no, in PR, D2 sir, considered R and S are final and I don't have any so for like in DFA I have P final, in DFA
so
2
you just
I
tell
have
me,
R and
let's
S
assume in D2 you have R, S are final in D2.
Yes sir.
Okay,
yes,
in D1 who are final?
Only P is final.
Okay, first of all, don't keep the same name. In D2, what are the names of your states?
Yes sir, R and S.
What are the names of the states in D2? What are your states? What are the names?
Like in my DFA, sir.
In your DFA D2, what are the names of the states?
Yeah. Sir, Q0, Q1 and Q2.
Q0, Q1, Q3. Okay. In your D1, what are the names?
Q2.
In your D1,
sir,
what are the names?
Sir, odd, मतलब 0, 0, 0E.
Okay. So right. So
Yes, sir.
okay, 0, 0, 0. Right.
E.
I got it.
Yeah.
Yes.
Yes, sir.
Then what is the problem now?
So, sir, like in a odd even problem, I have only one final state.
Which is
And
your
in
final state?
Sir, I have final state as odd even.
This is your final state, right?
Yes, sir. Yes,
Your
sir.
final state is this.
Yes, sir.
And there are other states like odd, even, and
Yes,
even
sir.
odd. These, yeah, right.
Yes,
Okay. And
yes,
here,
sir.
what are the final state?
Sir, only like Q0 and Q1 is final, sir.
This is final and this is final. So in your
Yes, sir.
D1 intersection D2, in your D1 intersection
sir.
D2, this type of state will be final. For example, if you have this state Q0 0E, if you have this state,
Yes, sir.
this definitely this will be final. But if you have this type of state, this will be non-final.
Got it, sir. Got
This
it.
will
वही
be
डाउट था कि
non-final.
मतलब तीनों होना जरूरी है. That I was asking. Okay.
तीनों मतलब दो ही तो हैं.
हाँ नहीं, जैसे Q0, Q1 और OE है ना, टोटल मतलब इनिशियली फाइनल स्टेट्स. तो कोई ऐसी स्टेट होना जरूरी है कि जिसमें तीनों हो, ऐसा पूछ रहा था. तो ओके, गॉट इट सर. की
तो इंटरसेक्शन का जो प्रोडक्ट ऑटोमेटा बनता है, D1 इंटरसेक्शन D2 जब आप बनाते हो, उसके अंदर फाइनल स्टेट वो बनती है जिसके दोनों कंपोनेंट्स फाइनल हो. मतलब ये भी फाइनल होना चाहिए. हाँ, और ये भी फाइनल होना चाहिए जब आप इंटरसेक्शन का बनाते हो. Okay. So this we have seen in the product automata. In the product automata lecture, these things we have seen. Maybe you can revisit if you have any doubt, but this is the answer. Okay. Yes, sir, any other doubt?
Thank you. मैंने सर एक्चुअली देखे थे वो सारे प्रोडक्ट ऑटोमेटा लिखे भी है कॉपी में, बट ऐसा कोई भी केस नहीं आता जिसमें तीन हो, उसमें
तीन
हो
है नहीं ना. अरे तीन नहीं है. आपके D1 ऑटोमेटा के अंदर सिर्फ ये स्टेट्स हैं. ये एक स्टेट है, इसको दो मत कंसिडर करो. ये एक स्टेट है, ये एक स्टेट है, और ये एक स्टेट है. ये D1 के अंदर टोटल 4 स्टेट्स हैं. ये एक स्टेट है.
इसमें तो एक ही फाइनल स्टेट है, बट D2 के अंदर हमारी दो फाइनल.
ये फाइनल स्टेट है. इसमें ये फाइनल स्टेट है. आपके D2 के अंदर 3 स्टेट्स हैं, Q0, Q1, Q2. इसके अंदर ये फाइनल है, ये फाइनल है, ये दोनों फाइनल. इसमें ये फाइनल है.
तो टोटल 3 फाइनल हो गए ना सर. तो मुझे लगा कि ऐसा स्टेट होना जरूरी है जिसमें Q0, Q1 और OE तीनों.
ठीक. ओके. लेकिन ऐसा तो कभी होगा ही नहीं ना, क्योंकि कोई भी स्टेट आप प्रोडक्ट ऑटोमेटा में बनाओगे उसमें सिर्फ दो कंपोनेंट होंगे. एक स्टेट D1 से आएगी, दूसरी स्टेट D2 से आएगी. कभी ऐसा हो ही नहीं सकता कि ये दोनों एक साथ आ जाएं. कभी ऐसा हो ही नहीं सकता प्रोडक्ट ऑटोमेटा के अंदर. कभी ऐसा हो ही नहीं सकता, क्योंकि प्रोडक्ट ऑटोमेटा में बेसिकली क्या होता है, यू आर रनिंग टुगेदर. अरे D1 D2 राइट, दे आर रनिंग टुगेदर. प्रोडक्ट ऑटोमेटा का मतलब ही होता है कि ये एक ट्रैक है, इस ट्रैक के ऊपर वो लोग दौड़ रहे हैं. दोनों DFA हैं, वो दोनों DFA इस ट्रैक के ऊपर दे आर रनिंग पैरेलल. सो ऐसा मतलब अगर मान लो D2 है, ओके, वो अगर Q0 के अंदर स्टार्ट हुआ, तो क्या ऐसा हो सकता है कि आपके पास दो स्टेट एक साथ आ जाएंगी, Q1 Q0 Q1 एक साथ आ जाए? ऐसा हो सकता है क्या? नहीं हो सकता. ऐसा तो कभी हो ही नहीं सकता. तो वही तो मैं बोल रहा हूँ कि प्रोडक्ट ऑटोमेटा के अंदर ऐसा तो कभी हो ही नहीं सकता, क्योंकि प्रोडक्ट ऑटोमेटा क्या होगा कि ये यहां से मान लो ये P0 से जोड़ना चालू हुआ, तो क्या होगा, ये जब A देखेगा तो ये P1 चला जाएगा, ये जब A देखेगा ये ज्यादा Q1 चला जाएगा. सो बेसिकली व्हाट इज हैपनिंग, इस P0 Q0 स्टेट से, ये जो P0 Q0 स्टेट है, इस P0 Q0 स्टेट से आप जब आपने A देखा तो आप चले गए P1 Q1 के अंदर. ठीक है, सिंपल. तो जो आप बोल रहे हो कि ये दोनों तो एक साथ कभी आ ही नहीं सकते प्रोडक्ट कंस्ट्रक्शन के अंदर, प्रोडक्ट ऑटोमेटा के अंदर ये दोनों एक साथ तो कभी आएंगे नहीं.
हाँ, ये सर ने है भी नहीं सर.
Okay. Any other doubt?
No, sir. Thank you.
Anyone has any other doubt in this session? Please tell me. Anyone has any other doubt? Let me know. Please tell me. Did you understand so far all the questions that we have seen? The discussion that we have done? Did you understand? Okay. So let's meet tomorrow. Tomorrow we will continue this session. This homework one, these questions we will continue in tomorrow's session. Okay. Thank you.